Right, so you just take that apron plastic off by unscrewing it, and then you've got two display units, your score unit and your ball and credit unit. I reckon we can probably tap onto the voltages on one of these capacitors. I'm going to check the schematic. That one might be a little trickier, but I'm sure we can do it. Also, while we're in here, let's clean all this crap off as well, make it look a bit nicer. I also note there's some bulbs that I haven't seen lighting. Where's the apron? 1 second. So we've got a game over, match, and a tilt light. So I don't know if those work or not, so we'll check those out. Right, so negative lead on the positive of C4, positive lead on the positive of C3. That should give us our positive rail voltage when we close the coin door. We're getting 87, 88 volts, which is fine. We're also getting flickering, so we might have to reseat the display glass on this, which I don't really want to do because I'm imagining it's pretty fragile. Let's just check for AC ripple as well. And I don't know how you do on this meter. Yeah, it's pretty much no AC ripple. So let's just check the negative rail as well. Right, and the minus is spot on pretty much, minus 90 volts. In a rare event, both the ball and credit displays are on. That may be because I just cleaned up the edge connectors on these boards. Don't know if that helped, but those are lit up for the first time together. The 1 up to 4 up are a bit flickery still, so this module, this glass module, sits in like a finger connection. Oh, it's come on now. It sits in a finger connection. It's potential that the finger connectors are dirty, so we might need to clean those. However, I said I don't want to mess with those if I can avoid it. And the fact it is lit up like that, fine, after it's warmed up for a minute, I think I'm probably going to leave it alone for now. Obviously, we've got some issues either with the CPU board or the display board that's causing this that we need to deal with at some point. One thing to note as well is the lamps under here are lighting up, but super dim. You probably can barely see that. So we've got an issue there to address as well. Right, I'm just going to make note of all the lamps that I need to deal with. Obviously you can see that the tilt, the match and the game over do light up now. They're not brilliant. I could do with 2 bulbs in there, for example. Right, so we've got 3,000, 6,000, 8,000, 10,000, 20,000, 30,000 all out. C, T, got the 3,000 here, 5,000 there. We've got the 3,000 advance there. Those rollovers are working. Extra ball and special. The 500 when lit. Rollover the B. And is that it? Well, I'll say that's it. That's a lot. But yeah, I'll go work for them all now, see how many I can get working. Oh, sorry, and the pop bumper on the right as well. So I just had a quick test play. One thing to note is these displays are working correctly and counting correctly now. The player's score actually counts once you've started a game, but it starts off with these 7s on it, so it's almost like the RAM is being initialized with the wrong values. It's potentially a CPU board problem there. Not sure how important it is, as it does seem to count. I'm going to check all 4 players can actually count properly, but yeah, I think it's potentially a RAM issue there. So just to show you, so when I start a game, it goes back to having these 7s on, and then it has the 0s correctly there. Let's try starting a 4-player game. So it just put all the 0s in, but it's got these random 7s. So is it going to count properly? Let's try. So once it gets to a point where it clears out that 7, it appears to be counting correctly. However, if you notice, the 1 up is getting switched on and off. It's going between bright and dim. So yeah, there's definitely an issue there as well. I was playing around with it on this 4-player game. Whether or not these are lit up is determined by the score for all 4 players rather than actually showing which player's up. That does indicate that the board is outputting the wrong values. Like I say, I'm starting to think memory issue here. So yeah, we'll be looking at that. Right, so I'm just playing around with this display fault a little bit. So I'm going to increase the score by 100 at a time. So it's on 160. So 1, 2, 3, 4, 5, 6, 7, 0. So 0 instead of 8. 1, 0, 1. So we're potentially missing a bit there, it would seem. Right, so I'm going through every bulb holder. I've got my bench power supply again. I'm testing each one. So this one's obviously not working. So one thing I'll do if it's not working is I'll check the bulb works. I'll clean the inside of the holder. And in a lot of cases, what happens is the tab no longer makes contact with the springy part on the end. So as you see, when we clip on there, it works. So the fix for this, obviously you can replace the bulb holder, but this has got like 20 plus faulty bulb holders, and these are a couple of quid a piece. And it's my own machine, so I don't have to put new bulb holders in. We can basically move the wire and solder it onto the end of here. Just sand that down a bit, we'll file it down, put some solder on, and you can move the wire, and then that gives you some more life out of the bulb holder. Oh yeah, and I've just found that captive ball lamp on the right drop target, the one I forgot to check before. That one doesn't work because that socket has fallen apart, and I need to remove that because that will potentially short out a lighting circuit. So let's get that removed. Right, so we definitely have more lights working, but there are some that are still not working, and I'm fairly confident I've been through all the sockets and bulbs now. So what are we missing? We're missing the seat. I don't know if that comes on in track mode, but same player shoots again. 20,000, 30,000, whatever that is, 10,000 or something. Yeah, that's a 10,000. What else are we missing? I don't think I actually got to that one. I didn't see where that one was, so I need to revisit that one. We're missing a 5,000 and a 3,000. That looks like it's lining up, but that's just that one in the middle that's shining through. What else have we got? Extra ball and special. I know I've definitely tested those. One up there. I know that one does come on sometimes. So these two. That one I need to check on the play field. Those two, and then the bunch there. And the C. Okay, let's see if there's any common drivers between those. Right, so I've been going through the lamp schematics, and I've written down all the lamps that are out. I've written down what connector they're on, what pin they're on, and which strobe they're on to see if I can find anything that's common. The strobes are pretty mixed, the connectors are mixed, so no commonality there. So then I've gone on to mark down the driver and the pin. So these are the 2003A, I think they're Darlington drivers, to see if there's a common theme. And you'll see that B17 shows up a lot. And also A17's got a couple of spots. But B17 looks like it's dead because how many have we got? Like 6 on B17. So let's try replacing that. I mean, it's possible it's not being addressed correctly, but I think it's going to be dead. Right, so I've got this running on the bench. It's in a track mode. I've got an LED hooked up to the positive, and I'm going to use the negative and basically touch this on to the drives, and you can see that flickering away. And anywhere there's nothing, like so, I'm marking a little blue line. So it basically goes up to here. This one, obviously there's an extra lighting circuits here that are not connected to anything, so it's only up to here, and it is on both sides. So we're going through them all, and we're going to identify if any of these ICs are dead. These are the Darlington output drivers. We need to check that they are actually being addressed if they're not working. Right, so I'll explain how these Darlington arrays work. So pins 1 to 7 are the inputs. So if we get a logic probe on there, the positive pulse is basically triggering the Darlington transistor. So we've got 1, 2, 3, 4, 5. 5, yeah, 5 didn't do anything for a second then, but 6, and then 7. 7 is low, so the output of 7 won't be doing anything. That is the common ground on pin 8 as it's switching, but these transistors are switching to ground. 9 is the common, which I don't think is used on these boards, so it's nothing. 10 matches up to 7. So as we saw, 7 was low. 10 should be doing nothing. And that is correct. 10 is doing nothing. And then 11 to 16 should be grounded as they are switching on. And we obviously tested that with an LED connected to 5 volts. So this one, A17, appears to be working. This is B17, I think. Yep, 17 is there. This is B. So this is the one that we think we're having some problems with. So we're looking at 1, 2, 3, 4, 5, 6, 7. Okay, so it's not the driver that's at fault. This is not being addressed. So we've got nothing on the inputs, so let's just pick an output. I'm going to have nothing on the outputs. So we need to look at the schematic and find out why this isn't being addressed. Right, so these drivers are controlled by these 8-bit latches. So the way these 8-bit latches work is you've got 3 address lines. So there's 8 output bits. You've got 3 address lines. You can see the address lines are actually common across the chips. So let's pick this one here. Right, so we've got address line A, B, and C. Those are selecting which output you want to write to. And then there's a data pin on pin 13, which is low. So basically, as those are all being selected, that is being set to low. So all of the outputs, let's just pick an output, are going to be low on this one, which they are. So that appears to be working as expected. However, why is it always low? Why is the data pin always low? So let's go to this other latch. So again, we'll see it being addressed because it's got common addresses. And if we go to the data pin, we will see that there is activity. So there is pulses. So if we look at some outputs, so some of the outputs have values on them. But this one, like I said, if we go to the data pin, it's always low, so it's always setting the outputs to low. This one has activity on the data pin, so it's setting values. This one is always low, so it's nothing on the outputs. And this one has activity. So we need to find out why these data pins on these two are low, as it's basically making so the latch is always setting all of its outputs to low. Right, so to find out why we have no data at the data pins on these latches, we're going over to the CPU section. So CPU has 8 data lines, D0 to D7, and some of those are directly connected to things such as RAM and ROM. And then because each pin CPU can only drive so much current, and this needs to connect to more chips, there's also buffers here. So you've got these 2 buffers. So you basically get your data lines go into the buffer and then come out of the buffer, and then the buffered output can then drive more chips. So this is D2 coming from the CPU. That's the input. and that's the D2 buffered output. And you can see, so you get a pulse on the input, you get a pulse on the output. This is D3 input, so it's coming from the CPU, and this is D3 output on the buffered side, and you can see there's a problem. So we've got pulses on the input, low on the output. So this appears to be an issue, is that low data, that buffered data 3 goes to the data input on this latch here. So it looks like we've got dead output on this buffer. Right, so I've desoldered the old chip and I've added a socket. Now, there is actually a bodge wire on both of these buffers, as Atari seems to have forgotten to add a ground trace to these ICs, so they've jumped them from the main ground over directly to pin 7. As I've now put a socket in, it's going to be hard to actually do that on the top, so I've taken off the bodge wire and I'm going to basically do it on the back of the board instead now. Right, just to verify that we've removed the right chip, we'll put this on. And it doesn't like that chip. So let's see. No, it will not. Does not like that at all being in. Let's put it to 7408. And we'll test it. And it's a fail. So yeah, we can be pretty confident that chip is bad. Let's go and grab a new one from the parts bins. Right, I've grabbed a new one from the parts bin. Let's test this out. Okay, that one's bad as well. Let's just okay, weird. Okay, I've got a different brand. Let's try this one. Okay, that's better. 748 found, and it passes. So, okay, I'll throw that Texas Instruments one in the bin. That one does not work. Right, let's get this installed on the board and see if we've made an improvement. Right, our new chip is in. It's powered up. We've got our test LED again, which I would like to be in the camera frame. And let's try these pins that were not... Okay, straight away, we've got a bunch of pins that were not working. There's one over here as well. Fantastic, so these are all working now. I'm actually surprised it worked as well as it did with a dead buffer on the main data line, so that's pretty important. That might actually explain why we also have display problems and loads of switches that weren't working. I haven't even started to investigate the switches yet, but I reckon when we put this board back in the game, it's going to be a lot better. Right, let's see how much things have improved since that last CPU board fix. So fire on. Oh yeah, we definitely got more lamps. Oh, and we've got 8 on the displays now instead of 80. So that's cool. So that seems to fix that display. Although we've lost the 1 to 4 ups. Don't know where they've gone. But yeah, we've got 8s on everything else. So let's have a look at the lamps properly. So that captive ball light doesn't work as I've taken the socket out already. We've got a 7,000 bonus, and that C isn't working. So there's only 3 that are not working. One of them is because of the socket. Those 2, I've definitely checked the sockets already very recently, but I'll check them again. It is possible there is still a drive issue on the board that we might have to address. I wonder if the switch situation is any better now. If we've got improvements on displays and lamps, let's try switches again. Right, let's just coin up the game. Oh, that sounds different. Okay, so sounds are different as well since fixing that problem with the board. Let's start a game. And once the switches sound different, I'm not overly familiar with Atari games. That does sound like it's got an extra high note on it now. Okay, good start on those switches. These need adjusting and cleaning still. Oh yeah, there's definitely some different sounds now. I did think it sounded weird before. Okay, cool, so all that's working at the bottom. Spinner doesn't work. Drop works. Drop doesn't work. Drop works. scroll if it doesn't work. What else have I got? So the right captive ball doesn't work. Oh yeah, we've got these ones here. I haven't heard them do anything yet. And these, nope. No. No. Okay, so the switches aren't great still. Let's try the kick out hole. I've actually adjusted these kick out holes now, so they should all work. That one doesn't work. That one doesn't work. What have we got here? Switch there. I doesn't work. K doesn't work. Okay, I think that's everything. So there are more switches working, but what I'll do next is I will clean up the switches to see if we can improve anything. Right, so I've cleaned every single switch. They weren't that dirty, so someone has cleaned them before me, and cleaning them has made no difference. There's not a single switch working now that wasn't before. Therefore, we have certainly got a board fault to investigate, so I'm going to write down every switch that's not working, and then hopefully there's a pattern on a schematic, maybe an IC that's common between all the non-working switches, and we'll go and check that out.